I don't normally show. Okay, today we're going to be discussing lines, and I'm not going to try to define a line. I'm assuming everyone knows what a line is. And we're going to be looking at equations of lines. In algebra, we always want equations, don't we? So, in general, we've already mentioned this semester when we were doing our little graphing tools, if there's no exponents, no square roots, no absolute value bars, then the graph is a line. In general, if you have an equation that looks like this, ax plus by equals c, where x and y are the variables and a, b, c are just numbers, then this is a slanted line. So if there are two variables in your equation, then we have a slanted line. Now, there aren't just slanted lines. There's also vertical and horizontal lines. So, if there's only one variable, then the line is either horizontal or vertical. So you'll have equations either with x's and y's. If there's both an x and a y, it's a slanted line. If there's just one variable, either an x but no y, or a y but no x, it's a horizontal line. And I'll show you how to graph all of those as we start doing these examples. I would mention though, if it's a horizontal line, the letter that's going to appear in the equation is a y. If you can write the equation in the form y equals a number, you have a y but no x, horizontal, and x and no y would be a vertical line. And it's exactly the opposite of what most people think at first. They think horizontal, that's the x-axis. Oh, I just moved the little camera.
How to make a good first impression to
this
a twin
is not,
brother.
Oh, okay, yeah.
How many times have we done that before?
Actually, I don't recall knocking the thing around. But when we start actually drawing horizontal and vertical lines, the way you'll remember this is the axis that the line passes through. It passes through there. If you drew a vertical line, vertical is straight up and down, it's passing through the x-axis. And I'll show that as we do examples problems 2 and 3.
I'll be quiet now.
Oh, no, please join in and say whenever you think you need to, there's something you say that I should have said, or that I'd have it said. Oh, another word I wanted to mention, intercepts.
Wait up, let me switch back over here. Okay, I've learned how to do that.
Intercepts, that's where the graph crosses either the x or y axis. The x-intercept would be where the graph crosses the x-axis. Remember, the x-axis is the horizontal one. The y-intercept is where the graph crosses the y-axis. If you think about this, if you had an x-axis and a y-axis, if you were going to draw a slanted line, then it's going to have both a y-intercept and an x-intercept. There's both of those. But if your line is vertical or horizontal, you don't have both intercepts. Like a horizontal line, it would have a y-intercept because that's what it's passing through. A vertical line would have an x-intercept. Right? So our first example. Okay, switch it. Let me write down the problem. It says, the coordinate of the, oh wow, there's not really much to write down here. I think I need to make it a little smaller so we can see the graph. There, better. The first problem is designed to see, do you know what these intercepts are? It says, find the coordinates of the y-intercept and of the x-intercept. Well, there's not a lot to do on this one. You know, sometimes you have the problems where you write it down and then scribble, scribble, scribble. You got to write to get an answer. This isn't one of them. We just look. Okay, the y-axis. Remember, the y-axis is the vertical one. Where is it cross? Oh, how to make a good first impression. Not first, second, third. What is this? 7th, 8th day of the semester? 9th? Anyway. So where is this graph crossing the y-axis? That's what it means by y-intercept. Is it crossing it at 2? But wait a minute. It's got to be an ordered pair. So I'm not just going to put a 2 there. What would this ordered pair be? Right here. Do y'all see where the cursor is? That's where I'm looking. What would that ordered pair be? I heard 0, 2. So I have to go parentheses, 0, comma, 2, close parentheses. Oh, and it's still a little too big. Let's see. Is that better? Okay. So that's where the graph crosses the y-axis. Let me check it. And now, okay, what's the x-intercept? Type a ordered pair. Oh, very good. 5, 0. It looks like it's crossing the y-axis at 5. If you find any old math books, by old I mean back in the 80s, the first time I saw any of this stuff, intercepts were defined to be numbers, not ordered pairs. If it asked what's the y-intercept, you would say 2. None of this ordered pair stuff. If it said what's the x-intercept, it used to be you just write a 5. Not this ordered pair stuff. Okay. Now, problem number 2 says, find the intercepts and then graph the line. Now, this one's going to take a little bit of work. Well, looking at problem number 1, that sort of hints at you, or trying to tell you, or give you a hint, how you find these intercepts. If you're given an equation, notice, you have a 0 for x, solve for y, a 0 for y, solve for x. So let me write problem number 2 down. Oops, what did I do? Problem 2. I'll write it down and then we'll do that one. It's problem 2. X minus 3y equals 3. It says, find the intercepts and then graph the line. How do we find intercepts? Well, do y'all remember some problems like this in that last homework assignment where you were graphing? In fact, I think it was the first 2 problems on assignment number 8, where you have a little XY table, and then you plug the 0 in for X to figure out Y, and a 0 in for Y to figure out X. That's what we'll do here. So you have to know, if you have a slanted line, how do I know it's a slanted line? Well, there's 2 variables in it. There's an X and a Y. So this is a slanted line. So you have to know, plug a 0 in for X, solve for Y, plug a 0 in for Y, solve for X. Fill in this table. So let's do the top one. Putting a 0 in for X, I would just have negative 3y equals 3. And how do I solve that for Y? I would Divide both sides by negative 3. So what would we get? A y equals negative 1. Okay. Now, let's do another one of those. Let's plug 0 in for y now. Plugging a 0 in for y. Oh, that's going to be pretty easy. If I put a 0 right here, for y, I would have x. Oh, well, minus 3 times 0 is just 0. So x, would it just be x equals 3? So there's the two intercepts. And I think I'm going to graph this. It's just a multiple choice one, so if you're doing this as a homework, you can now look and see which one has these intercepts. I'm going to go ahead and draw it out. I'm going to sketch my y-axis and my x-axis. So here's the x-axis. There's the y-axis. 0, negative 1, over 0, down 1. Right there. And then right 3, up 0. 1, 2, 3. So when I connect these dots, it's a slanted line. Again, I've done more than I need to actually get the answer. Okay? This is just a multiple choice problem. So let me see. Which one has those same intercepts? Oh, I was about to say it was A, and then I thought, no, it's not A, it's B. But no, it's not B either. Is it 0, negative 1, and 3, 0? I'm thinking that is C. Oh, at first glance you might think, well, wait, no. But look, I think 2, 4, 6, 8, 10. On this graph, each little line is 2, isn't it? So does that look like mine here? Yeah, it is. And even if it doesn't, there's the same ordered pair, 0, negative 1, and 3, 0. Okay? So which one was that? Was that C? Okay. So if you have a slanted line, to find the intercepts and to graph it, you plug in those zeros. Plug a 0 in for x, solve for y. Plug a 0 in for y, solve for x. That's what we were doing on assignments 1 and 2, or problems 1 and 2 in the last homework assignment. Now let's see, what about the next problem? Okay. Graph this line, x equals. Well, is this going to be a slanted line? X equals 2 is not a slanted line. If there's only one variable, it's either a horizontal line or a vertical line. So, and my brother wrote there, if it's in the form y equals a number, it's horizontal. X equals is vertical. The way it's exactly, most people think the exact opposite. Okay? Because the horizontal axis is the x-axis. But this is the axis it's passing through. Keep that in mind as we do problem number 3. Let me write it down. Graph x equals 2. Problem 3. Okay. It's not hard to do this, but how the heck do you remember if it's vertical or horizontal? Since there's only one variable, it's either vertical or horizontal, and here's how I suggest you remember it. This is the axis it's passing through at this number. the line passes through this axis. At that number. So, it's either a vertical line or a horizontal line. Let me draw my rectangular coordinate system. If you remember that the letter on the left is the axis it's passing through, then it'll be very easy for you to graph these. Let me show you what I mean. Ooh, no, I don't want that. Let me do this. Oh. Okay, I'm graphing x equals 2. What sort of line passes through the x-axis at 2? I'm going to find the number 2 on the x-axis, right there. What sort of line would be passing through that? It's got to be a vertical line. Okay? That's why my brother said, if it says x equals, it's a vertical line. It's exactly the opposite of what you think. Most people think x-axis horizontal. No. It's passing through the x-axis. The only type of line that's passing through the x-axis is a vertical line. So there's not really a lot of work to do on that one. Let's see, which one is it? It's sure not A or B. Do I need to blow these up? You'll see it. That's a horizontal line. B's a horizontal line. Let's see. Looks like this one is passing through the x-axis at -2, so it's not that one. It better be D, is it? Yeah, it's passing through the x-axis at 2. That's a D. So if it's in the form x equals or y equals a number, it's a vertical or horizontal line, not a slanted line. Of course, it might not be in that form, x equals or y equals. Like problem number 4, let me write that one down. There's a little bit that we need to do before. Y plus 5 equals 0. Move this over. Y plus 5 is 0. This is problem number 4. Well, is it a slanted line? Well, no. There's only one variable. So if there's only one variable, you've got to have that variable by itself. So what am I saying I'm going to have to do? Yeah. Subtract 5 from both sides. Y equals -5. So we're going to draw a line passing through the y-axis at -5. Let me draw this problem number 4. There's the x-axis, the y-axis. I'm looking for a line that's passing through this axis, that's the y-axis, at -5. So let's locate -5. 1, 2, 3, 4, 5. What sort of line is this going to be? Vertical or horizontal? Horizontal. It is kind of tricky. The x equals is vertical while the x-axis is horizontal. Okay? But when we're looking at equations like this is the axis it passes through at this number. So I'm looking for a horizontal line passing through negative 5. It's not A, is it? It's not B either, is it? That looks like a horizontal line passing through positive 5, not negative 5. It's not D. D's vertical. It better be C. Is it C? Yeah. Okay. Now, before we do the next problem, I want to define slope. Slope of a line. The slope of a line. The slope of a line is a way of measuring the steepness of a line. I guess that's a terrible definition. All I'm doing is giving a synonym for slope. Okay? Measuring how steep the line is. It also shows us the direction. A line, let me give you the abbreviation. Slope is denoted with a lowercase n. If a line slants upward to the right, its slope is positive. M greater than 0 is the symbolic way of saying slope is positive. The line slants downward to the right, the slope is negative. So those are the two cases for slanted lines. There's two other types of lines. A horizontal line has a slope equal to 0, and a vertical line has a slope that's undefined. We're going to have a definition of slope as a fraction in a moment. So let me go ahead and make a note. When is a fraction undefined? When there's a 0 on the bottom, So a number over 0. Okay, so if you have a number over 0, in a moment we're going to give you a little slope formula. That's when you have undefined. The way we calculate the slope, go ahead and look at, the next problem. Number 5. There's two ways of defining the slope. One way, the geometric definition, slope is rise over run. Rise is the vertical movement, up or down. Run is the vertical movement, the horizontal movement, right or left. And I'm going to illustrate what the heck I mean by this rise over run as we do problem number 5. Here's problem 5. It says, find the slope of the line shown on the graph to the right. Let's see. Does this make it any bigger? Notice there's 2 points labeled here on the line. Can y'all see this dot here and that one there? Choose one of those points and move to the other one. If I were going to start here, I'm starting at the one on the x-axis. And I'm going over here to this one. First thing we do is up, down. If I'm going from here to here, in words, I'm going up 1 and then how? Okay, left to right. Left 2. So I'm going up 1, left 2. Problem number 5. There's really not much scribble to get this answer. Up 1. I know you don't see what I'm writing yet. Okay. We went up 1 and left 2. Up is positive. Left would be negative. 1 over negative 2, we normally would write that as a negative 1/2. Negative 1/2 is the slope of that line that I just showed up here. Oops. The slope of this line is negative 1 over 2. Now, there's not a lot of, you just sort of look. Now, I normally start at the lower point and move up, but it doesn't matter. Looking at this graph right here. Okay, looking at it like that. Oh, it didn't really make it much any bigger. If we had started at this point and gone to the lower point, what would we have had? We'd have down 1, so negative 1, and then what? Right 2, so positive 2. Negative 1 over positive 2 would still get you negative 1/2. Y'all see how I found that slope? Doing rise over run. Let's do one more of these. This is still number 5. I just said similar problem. Okay, heck, let's start at the top and go to the bottom. What would this rise be? It'd be down 1, so negative 1 over 1. And I'm not going to write that as a fraction. Negative 1 over 1 is just negative 1. Are there any questions on this rise over run? So negative 1. Now, problem number 6 says find the slope of the line. But instead of being given the the line, they just give us 2 points. So what you can do is plot the 2 points and then count. Rise over run. But let's suppose it wasn't a 5, 2. Suppose it was 51, 27. And instead of a 9, 8, suppose it was 90, 80. Do you really want to be counting? So here's a formula that you can use for finding the slope when you're given 2 ordered pairs. So here's another formula for us this semester. Something referred to as the slope formula. If you're given 2 ordered pairs, x1, y1, remember how we did those subscripts? Just to mean these are not exponents here. First x, first y, second x, second y. Here's the slope formula. You can use this instead of graphing or plotting the points and counting. Second y minus first y over second x minus first x. That y2 minus y1 will get you the rise, the x2 minus x1 calculates the run. Okay? So it's second y minus first y over second x minus first x. Those are not exponents. There are no exponents anywhere when working with lines. Okay? So let me write down this problem number 6. Okay. We have the ordered pairs. 5, 2, and 9, 8. And it says, find the slope of the line. Notice there's that option of undefined. It would be undefined if there's a 0 in the bottom of that fraction when we actually do the little formula. So let's look back over here. Just like I did with with distance and midpoint formula, I always label first x, first y, second x, second y. Oh. And now I'm going to plug in. See, the y, I'm plugging in right here. Y2 is the 8. Y1 is the 2. When I subtract the y's, I'm getting the rise part. And then run. X2 minus x1. So let's see, we have the fraction, what, a 6 over 4? Which we could reduce to, by dividing above and below by 2, what would we have? 3/2? Yeah. So this little slope formula lets you calculate the slope if you're given 2 ordered pairs. But if you want to do rise over run, you can plot them out and just count. But again, if the ordered pairs were pretty large, I don't think you want to be counting if there's like 30 or 40 to get the rise over run. Okay. Let's see, I think number 7's another one like that. Let's see. Okay, here's another problem. Just so you get practice using that slope formula, let me write it down. Problem number 7. I'll do this one just so I can say I've done something mathematical today. Oh, let's see. Let's shy away from red pens too much. Sometimes people have trouble focusing on red. So. And you know, you're right, Tim. Red is the main... The problems say to find the slope of the line containing the pair of points. I'll cut you off. Red is the main. Color people that are colorblind have trouble seeing. And I go through periods where I don't use red, but then I start. But then Agnes buys all these great red pens for us, so we got to use them. Okay, there are the 2 points. We want to find the slope of the line containing those 2 points, and just like, let's see, I'm going to move it down. I'm going to move it. Also, I'm going to have the formula there. Hold on a minute. Is that minus there? Oh, wait, for this, just do. Oh, okay, there. Okay, there's the formula on top. Just like my brother does, I identify x1, y1. Just the first point I write down, I think of as x1, y1. Common mistake. People will say x1, x2. No. Order P. No, that's not an x. That 0 is what? A y coordinate. And then x2, y2. And I'll rewrite the slope formula. y2 minus y1 all over x2 minus x1. So I can now push this thing up, so there. And, okay, what's going to go here? No, wait, there's my minus and my minus from the formula. What's going to go here? 7 minus, here, 0, I agree, the y1, all over, here, 8, x2 is 8, and 8 minus 2, I agree. And what's that going to give us as our slope? 7 over 6 for 7/6. Wait, don't do it. Let's see. I'll come over here. There. And I don't select it. It's undefined. It's undefined if the denominator were 0. Okay, the slope was 7 over 6. Okay. I think the next one's going to, surely there's going to be some that regenerate with negatives in them. Let's see. Okay, finally, number 8 has a negative in it. So let me write that one down. Do you want to do it, Tim? You think I can? I don't know. I don't know. These negatives, you know, I can have trouble with those things. So, but I'm going to try. Okay. This is number 8. And the line is passing through the points -4, 9, and the ordered pair 3, 5. Right now, let's take a moment for me to mention that everything I'm writing up here that Tim's writing gets scanned and stored where on my math lab. Y'all remember what it's called? Document sharing. So you have the videos, you also have the actual copies of what we're writing. Does it scan here, or do you scan? No, I scan it at home. But where's
Not
the
home,
scan? I'm in
the
an
office.
Yeah.
Okay.
There's no scanner. Look around.
I don't know. Okay, so there's my point. And what? Okay, so I'm going to find it. Oh, wait a minute. Remember, we want to identify our x1, y1, and our x2, y2. So I am losing my voice. I am hoarse and I'm losing my voice. It's like kicking a man when he's down, isn't it? Okay, so I'll let y'all tell me. What's going to go here? 5. That's the y2 here. Okay, so you have a 5 minus 9 on top. On the bottom you have, okay, the x2 is 3 minus, okay. Now 5 minus 9, we know that that's equal to -4, okay? But watch out down here. Okay, that minus and negative, that becomes a plus a positive, so I agree with the 7. 4/7, we can't reduce that. I'll just leave it like that. I guess I could put the minus. You put the minus in front.
Well, if you use the slash, it puts it in front automatically. Okay. Come over here.
Type the click and -4/7.
See?
Okay.
I wish the students last semester in the MC building could come back and see how we can do it now, rather than. There's still one thing I haven't mastered, and that's actually writing on the screen with the mouse.
Oh, that's so hard to do anyway.
But
I look like I have Parkinson's. It's so shaky.
Okay. So now, I'm going to write a little bit. The next thing we're going to do is something called the slope-intercept form of a line.
Oh, wait, I didn't switch over.
Well,
There.
Slope-intercept. Wow, I sound Texan, don't I? Intercept. The slope-intercept form of a line. We've already mentioned what slope was. Heck, we just finished doing that. And I mentioned the intercepts. Okay? The x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. I just love it like this. It used to be you'd write it on the board, and then, okay, now I've got to erase this to continue writing. And then if I want to refer back to something, well, no, it's been erased. So we've already discussed what these intercepts are. If you have an equation in the form y equals mx plus b, what sort of line have I just written? It has both an x and a y. Is this a slanted line? Yeah, it's a slanted line. If you have a slanted line, the equation of a slanted line written with the y by itself, then the number in front of x, that coefficient, is the slope. This number over here, together with the sign, is the y-intercept, or where it crosses the y-axis.
In old algebra books, intercepts are not defined as ordered pairs. They're defined as the number at which the line or the graph crosses the axis.
And you missed it when I said that.
Oh.
You had stepped out.
Oh,
So,
okay.
okay. But let's look at problem number 9. It says, find the slope and the y-intercept of this line. Well, this is one of the problems that there's not a lot of scribble. Do you talk about the scribble, Tim?
No, I can honestly say I don't think I've ever used the word scribble in front of a math class.
Until today.
But I guess you're right.
Okay, you just used it.
You're right.
You know, the quadratic formula, there's a lot of scribble, right? You can't just get the answer by looking at it. But here, is this line written in slope-intercept form? Yes. Tim, go ahead and switch it on over. Even though, so I can see, just so they can see what I've said. If it's in the form y equals the number in front of x, that's the slope. So here's my rise over run. I don't know why I'm writing out the word slope. M stands for slope. And over here, this is the y-intercept from the 1980s definition. Okay? If it's passing through the y-axis at 10, we have to write that as an ordered pair. 10 on the y-axis, what would that ordered pair be? Is it 10, 0 or 0, 10? 0, 10. Okay? So I did do a little scribble just to show my thoughts. Okay?
So -6/7. And you'll notice for the y, they're making it easy for you.
I don't think it's like that on the next
I
one.
bet it isn't. They've already set it up as an ordered pair.
0,
so you know that what goes here? 10.
10.
Okay. Okay, so next one.
So if the line has y equals, that's in slope-intercept form, the coefficient on x is the slope. Let me write down problem number 10.
You know something? I think I should write that earlier. I think I should there. Is that better? I keep forgetting y'all are looking at all these projectors, and what's perfectly clear here needs to be bigger over there. So, can y'all see that? Yes.
Y equals 1/3 x plus 8.
I bet you the class can beat you, okay? Y'all tell me, what's the slope? 1/3, okay.
Not much to do to that.
But be careful. Looking at the y-intercept. Oh, well, they do tell you. At least they remind you here. What do they say?
Type an ordered pair. And you might, I did something, flip it back over so they can see my writing.
Okay.
Right here, I stuck this on there. This B is the y-intercept, so you write the ordered pair 0, comma. So what's that y-intercept going to be? 0, 8. There, go ahead and type it in.
Oh, I'm going to type it in. You think I can, Tony? 0, 8.
When you're typing stuff in with my math lab, never hit a space key, never use capital letters. And it's got to get harder, right? I think number 11 has just proved it's going to get harder. What's harder about number 11? The y is not by itself.
It's in standard form, this equation. You got to solve that thing for y. Well, this is a pretty easy one to solve for y. I'm talking just to see what does my voice sound like since I'm standing away from that hub.
Oh, it sounds fine.
It does?
Yeah, it records it all. If you've watched them, you can hear the students answering and stuff.
I used to tell my classes when I was recording using the old document cameras that they needed for them to answer back when I asked a question, and it didn't matter what they said, whether it was right or wrong. The microphone wouldn't catch it, and I would just go on, "That's right, that's right." So
and repeat, and then say the correct
and say the correct answer. Okay, and now we use and someone will say circle formula, and I'll say right, the quadratic formula. And so even if they got it wrong, it would have been recorded anyway. So I always made sure my classes seemed like geniuses. They never answered a question wrong. Okay.
Let me go ahead and
get through with this. We're never going to get finished.
Well, you've got to flip it over. Okay, so up we move. Notice, if it's in the form, we know how to find the slope and y-intercept if it's in the form y equals. So here we have that extra step. What am I going to have to do? There's only one correct first step here. Yes. Subtract 8x to get it in the form y equals, then it'll be a negative 8x and a plus 6. Now, is there any more scribble left to do? Well, not really. Here the slope is just an integer. It's not a fraction. And what am I going to write for the y-intercept? It'll be a 0, 6. Go ahead and type that in to see if I got it right. Sometimes students want to write it as negative 8 over 1 just to make sure it's rise over run. But don't. I think if you do that, it's going to count it wrong. My lab wants the fractions reduced as much as possible without mixed numbers. Okay. Let's see. Any questions there? Are we ready for another one? Oh, I think number 12 is still another one like that. Okay. Now this one's going to take a little bit more work, isn't it? To get it in that form y equals. So let me write this one down. Number 12. 10x plus 5y equals 20. Oh wow, 5 minutes we'll be ready for a break, but we're on problem 12 out of 15. Y'all want to take the break, or do y'all just want to go till we're finished? Oh, okay. If you need to take a break, you're always welcome to. Okay. So,
I'll do this one, Tony.
Oh, okay.
Okay, so I just get nervous standing up here doing nothing. I'm not used to that.
Yeah, me too.
I'm not used to the fact y'all aren't looking at this way, okay?
Some of them are.
Some of y'all are. It's just weird, and I'm...
day one, I did write up on the board, Tim.
You did it?
Yeah, they hadn't got the Abracam board.
What do you do between there?
Yes. It was it was still bigger space than in the old MC.
Yeah. You're right. Well, okay, anyway, so we want to find the slope and the y-intercept. That means we need to solve this equation for y. I'm going to move it up a little bit. Well, you tell me, what do you think I'm going to do first to solve this equation for y? Okay, so I'd want y by itself on the left side, so I'm going to leave that 5y there. And I'm going to move the x over, so that 10x is going to become a negative 10x. And I still have what? The plus 20? You see, I want to do the same thing. That's what's hard when you're there. And now, well, we still have something over here we don't want. The 5. So we're going to have to do what? Divide by 5. Now, if you think about dividing by 5, that's the same thing as multiplying by 1/5. And so you can distribute through a 1/5. That justifies this next step. Tony, what I do is I split it up. I divide each term by 5. Is that what you do? If I'd known that, I would have let you just keep on going. But that's the same thing as multiplying through by 1/5. And we can do that, multiply both sides by 1/5. So we can divide each term by 5. to give us y equals here, negative 10 divided by 5, I agree, that's a negative 2x, plus here, 4. I want to box that in, but that's not my final answer, is it? What's the slope? Negative 2, I agree. Now the y-intercept, I'm going to have to write it as an ordered pair, 0 and 4.
The y-intercept has the number as the y value, okay? The other thing, the x is the 0, okay? The y-intercept.
There's the y-intercept, the number is the y value.
So negative 2, 0, 4. If you do this, 0, 4, what is it going to say? Or if you, heck, if you just put a 4. You just put a 4, it's going to say, oh, it must be in the form of an ordered pair. It's saying make sure you've enclosed your answer in parentheses. Well, you got to do more than just that. You got to have the parentheses, 0, comma, right arrow. There, that looks right.
Any questions? Okay.
Well, in algebra, we always do it one way, then do it in reverse. Here, in the other equations, or problems like, at least for problems, let's see, here, you're given the slope-intercept form. What we're going to do on the last 3 problems, well, I don't know why. But starting with number 13, we're going to actually have to find an equation of the line given the slope find an equation of the line having the given slope and containing the given point. Underneath there, it says the equation of the line in slope-intercept form. So we're actually going to write slope-intercept form for this line, when all we're given is just one point and the slope. So this is problem number 13. Why not make that m equals 7 a different color from the ordered pair? So our answer is going to be in the form y equals, and you're going to type in a mx plus b, but you not got to know m and b. Well, actually, I think we're told m. Is you ready to start working it through? Ooh.
What did I do? Did I move the camera?
No, I just moved the paper.
Oh, so you don't use that template there? No. Oh, okay.
Well, I mean, you'll find yourself moving it and spread it.
So we want our equation in slope-intercept form. Y equals mx plus b. Is that legible? Yes. Okay. Now, the equation, our final answer is going to have a y and an x in it. The letters that we don't want here are m and b. And we know m.
What are we going to replace m with?
7. So a 7x plus b. The problem is they didn't give us a b value. They didn't tell us the y-intercept. Is this a y-intercept? Is that point on the y-axis?
No.
No, if you plotted 4, 1, it would not be on the y-axis. It would have been nice if they just said through 0, 1, but they didn't. Here's the trick. They didn't give you a b, but they gave you an x, y. Looking at that point, what's the x value of this ordered pair here? 4. So there's x. What's the y value? 1. So plug in 1 for y. We have the 1, write the y.
No,
we have the y, write the 1. So you have 1 equals 7. In place of the x, what am I going to put? A 4, I agree. Plus b.
in the future, you might not want to show the 7 times 4, but you just put what number there?
28. 7 times 4, I agree, is 28.
So now,
oh, my green pen is beginning to go.
Maybe this one will be better.
Okay, well, I won't use green right now. I'll use black. So we now have an equation containing just the letter B. We know how to solve this equation for B. What do I need to do to get B by itself? Subtract the 28, move it over, change the side and the signs. So all we have over here is what? B equals...
Lift up.
Oh, no.
And you see why I position it up
wow.
here
Yeah,
so you can lift it up.
B equals 1 minus 28. I can't hear you. Negative 27. So,
I think you can go right up here.
I got to come right here. I'm going to take that negative 27. I'm going to come up here, replace that B with negative 27. So what's my final answer? Y equals 7x. I couldn't hear you. Minus 27 for my final answer.
And notice how that's in slope-intercept form. The y is by itself.
Okay, I have a question for you. What number, if you drew the graph of this line, at what number would the graph pass through the y-axis? At negative 27. That line, if we drew it, there's negative 27. It looks like that.
How do you know it's slanting upward
instead of downward? Because of a positive slope. Okay. You better type in the next.
Slope is positive, so it's slanting like that, passing through negative 27. That was a good question to ask, Tim. Let me type that in.
I just didn't know if you told him that.
Y equals 7x minus 27. I haven't said it, so I better say it. 20 short years, we'll be finished. Well, actually, only 2 problems. We should be able to get each one of these done in about 6 months. So
I'll let you take over. It seems like you were going faster without a colorful repertoire.
Well, we'll see about that. Number 14. But the reason I put this down here is so that when I'm... Okay, I got to move it up.
And you're not going to hit the
if you use the grid lines that they have, then you hit the camera.
Okay. Is that being recorded?
Yes. Okay, so in problem number 14, we have m equals 7 over 8. And the ordered pair that we're given is a 7, negative 6. Notice what color I grabbed and used when I finally get a chance to. It just stands out better. Well, for those people that can see it. I'm sure for the people that can't see it,
that's an incredibly obvious statement.
Okay, so we want to write... Oh, did it give you the y equals on this one or not?
I don't know. Look and see. Oh, I know how to do that.
Yeah, it says y equals. Okay, so we want y equals mx plus b.
And you know the m.
You know the m, 7 over 8. So I'm going to replace this m with 7 over 8. X plus b. Now, what makes this problem different from the others? That fraction. So I'm going to do something a little different. Over here, I just immediately plug the x, y in. I think on this one, it's easier if we get rid of the fraction first. We discussed getting rid of fractions from equations. There's only one denominator. What would I need to multiply straight through by that'll cancel out this denominator? An 8, you want to call it 8 over 1?
Remember, you're going to run that.
I know. 8 8, 8. So here's the equation at this point. It's no longer in slope-intercept form. Okay? Why am I saying it's no longer in slope-intercept form? It's not in the form y equals anymore. But I did deliberately get rid of the fraction because I think it's going to be easier now to plug this x and y in. So plug a 7 in for x and a negative 6 for y. And that's a 7 times negative 6. Ooh, is that going to be a negative 48?
Yes.
Y'all caught up with me? And what about right here? I'm not going to write 77. What's that going to be? Is that a 49? The 7 times 7, and the 7 is that red 7. So now we got to solve for b. Let's see, what would I need to do? I move the 49 over. Ooh, is that going to be a negative 97?
97.
Move it up. I want to know the number for b. So what do I still need to do to get b? Divide by 8. Excuse me. You said the right thing. Divide by 8, and I wrote a b there. Sorry about that. Divide by 8. So b is a negative 97 over 8. So we're writing in our equation y equals, the m is that 7 over 8. Then you type x. And the b is this negative 97 over 8. I'm going to put the negative right here. So a minus 97 over 8. Something you want to add to that, Tim?
No, I like what you did there. Is that something you always do?
No, last semester. Normally, when there's a fraction here, I suspect if you look at view and example, what it's going to do is go ahead and plug the 7 in. So you have 7 times 7 over 8, but you know it's 49 over 8. But it's just going to make it, I think, a little bit harder. It's easier just to multiply straight through by that denominator and then do this calculation here than to go 7 over 8 times the red 7.
Okay, so let's type in. And let's see, so that was y equals 7 over 8 x. Is that what I wanted?
No, that x should not be in
there. Remember, you got to do a right arrow before you type your x, and that's a minus 97 over 8. Is that what I wanted to type? Yes, it is.
Any questions? The way math just builds and builds and builds. We know how to find the equation if you have
a point and the slope.
A point and the slope. You see, here's an x, y, and there's the slope. Well, earlier, we were discussing how do you find the slope when you're given two ordered pairs. This stuff here. Remember that slope formula? If you have two ordered pairs, you can find the slope. Let's put it all together. Let's do problem number 15. We just have two ordered pairs. So can y'all think of the steps that you're going to have to do? You first have to find the slope and then do what we did on problem either 13 or 14, depending on whether there's a fraction or not. But let me write down problem number 15. 15. Problem 15. The ordered pairs are 3, 1, and 9, 4. So, okay, go ahead and flip it over there. Oh, notice you're still writing the equation, and it gives you the y equals.
So they want your final answer in slope-intercept form.
So, start off finding that slope. So, I'm going to use that slope formula. So, I'm going to go ahead and label x1, y1. First x, first y. Second x, second y. Let me go ahead and write down that slope formula. That's second y minus first y over second x minus first x. So plugging in y2 minus, what am I putting in place of y1? What goes down here? 9, 3. Let's see, are we going to get lucky and this not be a fraction, or is this going to be a fraction? Yeah, it's going to be a fraction. 4 minus 1 is 3 and 6. Okay. So, oh wait, 3 over 6, I'm not finished with that, am I? That reduces to what? 1/2. Okay. So m is 1/2. This problem here is now exactly like number 14. The only difference is on number 14 we had number 15 we have 2 ordered pairs. We don't need this one anymore. But here's an x, y, and here's the slope. Okay? It's the most classic problem-solving technique or strategy. If you know how to do one problem, when confronted with a new one, make it look like the one you know how to do. Here, m is 1/2. You know what? I'm going to write that out. M is 1/2. I'm writing it as if it's a completely new problem. And which ordered pair do we want to use? I guess we'd probably choose the one that's the smaller numbers, the 3, 1. Notice how I've now rewritten number 15, looking just at this, to be just like number 14. Alright? So, do you want me to keep going, Tim, or do you want to go over then? Okay.
Let's see. So, we know that y is equal to mx plus b. That's our slope-intercept form. We already know this letter here. I'm going to replace that with 1/2. But I like my brother's idea, the way he went through and got rid of the fractions before we started plugging in. That made finding b easier. And if you doubt me, then you do it without getting rid of the fraction and find the b. You got to get the common denominators and create equivalent fractions. So I like his idea of getting rid of the fraction. What would I have to multiply through by here to get rid of that denominator there? 2, so times 2, times 2, times 2. So I now have 2y equals 1 times x is just an x plus 2b. Lift it up some more. But not that much. Right there. Right there. What's acting like x? Okay, so x is 3 and y is 1. So we have 2 times 1 equals here 3 plus 2b. So, well, we know 2 times 1. 2 times 1 is, so we have 2 equals 3b, no, 3 plus 2b. What will I do next? Okay, I'm going to move the 3 over. I'm going to move that 3 over. 2 minus 3 gives me here negative 1 equals here 2b. So I'm coming right up here to solve for BI. Divide by 2. I'm sorry, I'm writing down so low there. I don't know if that's going to scan very well. So my B value is equal to, I couldn't hear you, -1/2. I agree. But the final answer, they wanted the equation, not the B value. So what am I going to type into my math lab? We had y equals, okay, 1/2 times x. So instead of saying plus and negative, I'll just say a -1/2. Tony, you were going to say something. I thought you were.
Oh gosh. At one point I thought, I got to remember to mention the extra credit for them to do the extra credit. I hope I didn't make any sounds when I thought of that. 1/2, right arrow, x. Notice how I never hit a space key.
No spaces, no capital letters in my math lab.
Oh, wow. Okay. You did it. I'm going to save this.
Now what do we do? Spend half an hour closing the wall and moving the desk?
Yeah, we're going to close the wall, move the desk. So, just a reminder.
You got to scan?
Yeah.
I can start up.
Just a reminder, the extra credit for test 1. What did we decide? What are those? It says it's due on February 25th. Here's my little low-tech calendar.
Well, we should
Okay.
get it done by Thursday.
It's due there, okay?
But if you have it done by Thursday morning at 8 a.m., you get 15 points instead. This is an all or nothing thing. You make 100. By Thursday morning at 8 a.m., you get 15 points added to your test grade.
That means we just add 3 correct points. If you made 100, 3 correct problems. So if you made 100, my math lab has 20 out of 20. We would just enter in 23 out of 20, which would raise that grade to 115.
And but if not, well, we don't have class on Wednesday. We'll do circles on Monday. On Tuesday the 25th, that's when that extra credit is due. And this is one of those assignments that isn't
We're not required. If you don't want to do it,
it will not. You can't. Once the due date passes, it's done.
You will not be able to
You can't
flip
keep
it.
working on it with a late penalty, because unless you make 100, you're not getting anything. So there's no late penalty on that. When you click on it, it doesn't say anything. Penalty. Okay. So if you have any questions, I'll try to answer them. Otherwise, I will see y'all. We'll see you. Hopefully, we will. Yeah,
Maybe.
1 week from today. We are right on schedule. We are at the same spot I am every spring semester. I always assume that there's build in a few days in case something happens.
Enjoy y'all's day off.
Yeah, enjoy your day off. Okay. I'm gonna stop the recording now.